Morning, Matt.
Good morning. How are you?
Good. How are you?
Oh, pretty tired. How are you?
Yeah, about the same. Ready for spring break.
Yeah, me too. Isn't that in a week?
Yep, we just have 4 days and then we'll have spring break. Yay!
That's good.
Morning, Annie. Good morning, Josh.
Morning. So next week is our spring break, right?
You got it. We were
Okay.
just talking about that. Yeah.
All right, cool.
How's everyone doing this morning?
Pretty good, just a little tired.
Yeah, I think everybody's a little tired. That's a Monday for you, right?
Yeah, that's true.
All right. So welcome back. We were just talking 4 days and then you get spring break, right? I mean, 5 if you have a Friday class, but we don't have a Friday class, right? So if you don't have classes on Friday, you just got to make it through 4 more days and then you get a whole week. How many of you need a week? Yeah, for sure. Maybe some of you just need a day too, right? Seems like we don't even get a day. Anyone doing anything good for spring break? No, me neither. I'm probably working, right? Getting caught up on things, planning stuff. That's it. Nothing fun. My kids are on spring break starting today. So they're definitely not thrilled that I'm working, right? And they're on spring break. But I guess it's nice because I don't wake them up in the morning, right? Yeah, that's true. Okay, so last week, just to catch everybody up, you took a test, yes? You did your statistics reflection, I hope. Your score might not have been exactly what you wanted, right? And some of you, I suspect, ran out of time. I don't know that you ran out of time, but I suspect you ran out of time. If that was the case for you, I'm still looking at what I'm going to do about that. But not everybody ran out of time. So what I noticed was the most troubling part was the very last questions. right? Like questions 18, 19, 20, or for sure 19 and 20. And a bunch of you were confused, I think, on area to the left versus area to the right. Okay, or you just didn't read that part of the question, or it was just test stress or something. So, but I graded all of your written work and I wrote on it, like I hand wrote, you know, like on your paper. So you should be able to see that. So make sure you review my written work on your written work. Yeah, because that will be helpful. And you can always meet with me one-on-one and let me know what's going on. Can everybody else hear me? Brady says he can't hear me. So Brady, two things you can try. Oh, he can't hear me. So hold on. Let me type to Brady. You can check your mic in the lower left corner to see where your speakers are. Oh, good. Thanks. I was just typing to you, but now I don't have to. So we got to figure it out. Okay, excellent. So if you want to meet with me about your test, you totally can. Just come anytime during office hours or send me a message. What time is good for you? That was the longest test we take right there. So our next tests are much shorter. So like our probability test, I broke into two pieces. So we have like a quiz over PC1 to PC4, and then we'll have a quiz over the rest of probability. Okay. So that should break it up nicer for you instead of trying to do so much. That statistics test is a little big. I need to probably break that into two pieces. So, but overall, you guys did pretty well. We're still having some rounding issues, which I hope we'll discuss some of it today. But review my writings on there and let me know if you have any questions. Overall, you can look at your grade, you know, in general. That's why I had you do that statistics reflection. So you can see where you stand, even if you didn't get the exact grade you wanted to on that test, right? You can still see what your overall grade is in the class. So any generic test questions or anything like that, like don't ask me, on number 4, I wrote this, because that's not going to be helpful, right, to everybody. But if you have a question in general, even about future tests, that would be fine to ask right now in front of everyone. Any questions? Okay, so the biggest thing is we don't want to lose anyone, right? We want everybody to finish the class this semester. So if you notice that someone's missing, then, you know, like someday you need to reach out to them. You could just do it via Canvas, right? You don't have to, if you don't have their personal info, and just say, hey, we missed you in class. Where are you at? Right? Because we want everybody to pass. And spring break sometimes is detrimental to us because you don't want to come back after spring break. You're like, perfect, sounds good, see you later. You guys need to finish, right? You came, spring break is halfway through the semester. So if you made it halfway, you don't want to miss the second half, right? Because you just need to finish up. Some of you are graduating. Some of you, this is the only thing that's keeping you from getting further in your degree program, right? So let's get through this, okay? Reach out to each other if you need it, okay? If you don't come back after spring break, it will be devastating. We will be calling you, emailing you, harassing you because we want you back, okay? All right, so flashback to last week. Last week we did a dice game. Yes, we rolled dice in class and we calculated some information. We're gonna do more of that today. We're not rolling any more dice. We're just gonna evaluate our data today. So before we do that, we're gonna do a Mindfulness Monday activity. Let me make sure I can find it. And so I'm gonna share my screen with you. Remember, when we do our mindfulness activity, you can turn your camera off, that's fine, okay? All right, Oh, wait, I don't think I shared my sound. Hold on. 1 second. Okay.
Mindful breathing. Close your eyes and rest your hands on your knees. Bring your attention to the touch of your body on your seat. Feel the weight of your body on your chair or cushion. Make sure that your back is straight and that you're comfortable. Take a few deep breaths. While you're breathing deeply, relax your shoulders, your stomach muscles, the muscles in your face, your hands, and your legs. Let go of all the tightness in your body. Now bring your attention back to your breath. Notice what it feels like as it enters through your nose, goes down through your throat, filling your lungs, and back out through your nose. Notice your stomach and chest rise and fall each time you breathe in and each time you breathe out. And just allow your breathing to be natural and relaxed. Now bring your attention to the feeling of your breath in your nose. Feel your breath as it comes in and goes out. Just focus on this sensation, paying attention to each time you breathe in and each time you breathe out. As you inhale, maybe your breath feels cool. And as you exhale, maybe it feels a little warmer. When your mind wanders, or if you become distracted, just notice what's going on in your head, and then gently bring your attention back to your breath, going in and out. Focus on the feeling of your breath and allow thoughts and feelings to come and go in the background. Now gently bring your attention back to the touch of your body on your seat and open your eyes.
All right. I really like that one. I don't know if you guys do, but that's one of my favorites. Some of you are like, now I'm sleeping, right? Hold on. All right. So some of you might have been like, oh, I'm getting sleepy after that. Her voice is making me very tired. So different things work for different people. So did any of you try meditating before the quiz, the test? Ruki says yes. Annie says yes. Some of you, if you are already doing fine and you don't need the meditation, that's totally fine. But some of you may want to try it because it is very helpful just to calm your mind. I don't know about you, but when I was doing that one, when she says, do you find your mind wandering? I was like, ooh, yeah, I think I was thinking about what I need at the store right now. Like, so probably not mindful breathing at that moment. So, but I liked that she knows that we do that, right? All the time. So that was really nice. So just try it. It's really good. It's really hard for some of us to silence our minds, right? Because all those thoughts just keep racing. So, okay. So now back to our rolling our dice thing that we did the other day. We did an experiment where you guys all played a game and you kept track of your dice. Well, I collected data for both my classes, right, in the same spreadsheet. And what I want us to do now is calculate the percentages, calculate those probabilities that things happened, that things, what am I trying to say? That how, like, what's the percentage of time we rolled a 3 or whatever. So if you copy that doc that's in the chat, it looks like this, except for I wrote all over this one already. So I will erase that, hopefully. Maybe. Okay. And don't worry about this bottom part because we're going to do the top part first. So in this top part, we rolled a total of 913 rolls between both of my classes. So we want to calculate the experimental probability of rolling a 0, for example. Well, for rolling a 0, 0 divided by 915 is still 0. So we don't have to worry about that. But then we can calculate like 31 divided by 915. And if you do that on your calculator and you round to the nearest tenth of a percent, you're going to get 3.4%. Does everybody see how I did that? I did 31 divided by 915, and then you could multiply it by 100, or you could just think of moving your decimal point. So it comes out to 3.38, which would be 3.4%. So what I want you to do is calculate the rest of these percentages. You don't have to write them on that worksheet if you don't want to. You can just write them on a piece of paper if you want. But calculate 3 through 12 for our experiment, okay? And when you're done, type to me in the chat that you're done, okay? So I'll give you about, I don't know, 2 minutes to fill in the rest of these, just on experimental. All right, I hope you guys are close to done. Are you close to done? I know Zach was done and Annie was done. Okay, so let's just go over this and see. So for rolling a 3, Annie, what did you get for rolling a 3?
I got 5.9%.
Yep, is that what everybody got? 5.9%? Any questions on that? Or are you okay? All right, let's look at, Zach, what did you get for 3? I'm sorry, we just did 3. For 4?
8.2.
8.2%. Excellent. Matt, what'd you get for 5?
14.1. Wait, I think.
I think that was 6.
Okay, 10.1 then.
Okay, good. You did 2 of them.
Sorry,
then.
2.
No, that's perfect. Janessa, what'd you get for 7?
I got 16.4.
16.4%. Excellent. Josh, what'd you get for 8?
For 8, I got 12.8 or 12.9.
I got 12.9. Did you get 12.9?
Yeah.
Okay, good. And then how about 9? Lily, what'd you get for 9?
I got 11 point, sorry, I forgot to write it down. 11.4.
Did you get 11.4, everyone? I got 11.5. Did anyone get 11.5?
I did.
Yeah, anyone have a rounding question there? If you do it, you do 105 divided by 915, and then you get 11.4, but there's a 7 after it. So since there's a 7, you need to round up. I noticed a lot of rounding errors on the test. Okay. All right, how about number 10? Ruki, what did you get for 10? 10, rolling a 10.
I got 8.7.
8.7%. Excellent. Brady, what did you get for 11?
Hello, can you hear me?
Yeah, what did you get for 11?
Oh, great. 11, I got 7.4%, but I don't think that's right.
Did you do 45 divided by 915?
Yeah, I probably put it in wrong, I think.
Okay, do it again right now.
Okay, yeah, I just got 4.9%.
There you go, 4.9. Does that sound better to everyone? Excellent. And Judith, how about 12? Judith, can you hear me? What did you get for 12?
Sorry, I thought my internet got out, and then I was like, I think she called on me, but I didn't hear her because my internet, it said internet connection is slow, and I was like, oh my gosh, I think she called on me.
Okay, so what did you
Okay,
get for
sorry.
12?
3.9.
Very nice, 3.9%. Is everybody okay with that? That makes sense. Excellent. And you might have noticed, which one was the highest percentage?
$16.49.
Yeah, and so it was a roll of 7. We rolled 7 more often than we rolled any other number. And you might have noticed that towards the middle, our percentages were higher, whereas towards the ends, our percentages were lower, right? So let's take a look at this. in regards to our theoretical probability. So that was experimental probability because we did an experiment and we calculated our results using our totals from our experiment. But we could find it just theoretically as well. And for theoretical probability, I could use a picture, something like this that you see on your screen. And I can put it in the chat in case you guys want to look at it for later. It might be a nice reference sheet for you. You'll have to fill it in. But remember, if we are doing the sum of two dice, if one of our dice is these outcomes, which are 1, 2, 3, 4, 5, and 6, and then our other dice is the same, but it's these outcomes, 1, 2, 3, 4, 5, and 6, then I can make this chart to figure out how many possible outcomes I have. So if you look to fill in this first box, I would say, oh, 1 plus 1 is 2. And then 1 plus 2 is 3. Oops. 1 plus 2 is 3. And then 1 plus 3 is 4. 1 plus 4 is 5. 1 plus 5 is 6. And 1 plus 6 is 7. Does everybody see where I got those numbers from? You okay? All right, so somebody tell me how I would fill in this second row across. What would you put there?
1 plus 2.
Okay, so tell me the answer to all those boxes.
So the first one's going to be 1 plus 2 is equal to 3, and then 2 plus 2 is 4, and then 2 plus 3 is 5, 2 plus 4 is 6, 2 plus 7 is 7, or 2 plus 5 is 7, and then 2 plus 6 is 8.
Very nice. And now you might be noticing a pattern, right? So what's the next row going to be?
Just it's kind of like the same pattern, but just start with 4 instead. Just go up.
Very nice. Very nice. So start with 4 on the next one, and it's the same pattern. So the next row will start with what number?
5.
5. So you're going to go 5, 6, 7, 8, 9, and 10. And the next row will start with 6, 6, 7, 8, 9, 10, 11, and then 7, 8, 9, 10, 11, 12. Does everybody see that? And you might notice, ooh, there's a really nice pattern. So if I'm trying to fill out this chart at the bottom, I'm going to say, okay, how many ways can I make a 1? Well, remember we talked about this on Thursday. If I'm rolling 2 dice, there's no way I'm going to get a sum of 1 because the smallest sum is going to be a 2. So, and then a 2, if you look at this chart, there's only one way to make a 2, right? And then if I look at how many ways to make, oops, how many ways can I make a 3? Well, there's 2 ways to make a 3. Yes? Everybody see those patterns? Very nice. So how many ways are there to make a 4?
3.
3. How many ways are there to make a 5?
4.
4. Excellent. How many ways to make a 6?
5.
5. And how many ways to make a 7?
6.
6. So if you're wondering where we're getting those, we're looking along the diagonals. So there's 3 ways to make a 4, 4 ways to make a 5, 5 ways to make a 6, 6 ways to make a 7. Now what happens when I get to 8? How many ways are there to make an 8?
5.
5. So it goes back down. Do you notice that? So we're going to go 5, then we're going to go 4, then we're going to go 3, and then 2, and then 1. So notice that's very similar to what our experimental data was doing, right? We had the most occurrences in the middle of our data. So how many total outcomes are there on this chart? Can you tell?
$36 outcomes.
Yep, there's 36 outcomes. So these would all be 36s here. Where did the 36 come from? There's 6 here and there's 6 here. So if I do 6 times 6, I get 36 outcomes, right? So there's 6 choices for the first dice. There's 6 choices for the second dice. If I multiply those two together, I get 36 total outcomes. Okay. So if you go back to that paper, now you can see all those are filled in. Can you calculate these percentages? Calculate all these percentages. This is going to be 0% again. This time we're going to do 1 divided by 36, which is going to give us 2.8%. And calculate the rest of those. After you finish calculating them, compare these numbers. Okay, tell me if you see any similarities and differences. And you can type those to me in the chat when you finish. Okay, you can just type them directly to me. Calculate all those percentages and then type to me in the chat any similarities or differences that you see. I'll give you a couple minutes for that. Okay, don't forget when you're done, you're supposed to type to me similarities and differences. I only have one response so far. Okay, so let's compare this data. So in your things, I see people are saying things like the theoretical has a bell shape and the experimental might also have a bell shape, but it might be skewed a little bit. Between both, they're relatively close in the numbers to each other. Like in 3, the experimental is 5.9, and in the theoretical, it's 5.6. As opposed to the previous experiment that was completely random, this one could be predicted. Well, this wasn't an experiment, right? This was just calculating the outcomes. And there steadily increases in the experimental, the numbers are more random. I'm not sure about that one. A similarity I found was in the 7th box that the percentage was the highest on both of them. And the percentage started low and got high and then went back low again. And the difference I saw was just a different percentage. Very nice. That's a very nice explanation. So if we have our numbers in here, if we put all our numbers in here, it might help you see them. So for our theoretical, we have, this would be confirm yours, 5.6%, then 8.3%, 11.1%, 14.9%, 16.7%, 14.9%, 11.1%, 8.3%. Oh, I think that's supposed to be 13.9, isn't it? Instead of 14.9. Did you guys get 13 or 14? For 6?
13.
Yeah, I thought it was 13. So 13.9%. This is 13.9%, and then 5.6% and 2.8%. So if we compare our numbers from here to here, we're a little bit off, right? Our ends are a little bit higher. Our 2s, right, are a little bit higher. And our 12s are a little bit higher. But I love when you were comparing the middle, you noticed that 7 was the highest for both of them. Yeah. So what's interesting is we came pretty close to theoretical results, even though we didn't have very many rolls, right, overall. So the difference between theoretical and experimental probability is experimental probability you calculate after you do an experiment, right? So you take your results of your experiment and you calculate the probabilities. Whereas with theoretical probability, that's the way it is. We don't have to do an experiment to find it. We just have to think about the possible outcome. The other thing that's interesting is the more we do an experiment, the closer our results will come to this theoretical probability. Okay, it's called Bernoulli's theorem or the law of large numbers. So the more rolls we did, like if I had you guys do it all over again, we would even get closer to these numbers. And I love that you guys were talking about that bell shape, because if you take a look here, this is a diagram of theoretical probability of rolling 2 dice. And if you look, remember our theoretical number was 2.8%. Look right there. That's where that top of that line is. That's what they're showing you. So on this side, it's the percentage or the decimal right here. And on this side, here's your fraction. Okay. So, and it does go up until we get to 7. And so 7 is the highest. And then it tapers off on both ends. So if you were going to play this game again with the cubes like we did on Thursday, what would your new strategy be?
Putting the cubes on the middle.
Yeah, put all your cubes in the middle, right? Probably between 6 and 8, right? You probably wouldn't put very many cubes down at 2 and 3 or 11 and 12. Now, that's not to say you're guaranteed to win, right? Because there still is a chance you could get some other numbers, but you've increased the likelihood. Yes? Okay, good. Now we're going to do a couple examples together. Okay. So you're going to roll 1 6-sided die now. What's the probability you roll a number bigger than 2? You roll a number greater than 2. You can give me your answer as a fraction, whoops, as a fraction or decimal, and let's say to 4 decimal places, or a percent rounded to the 10th. Okay, so you can give me any of those answers and we're going to type them in the chat. You're only rolling 1 die now and you want to get a number bigger than 2. Okay, I'll give you about 20 seconds to think. And then you're going to put your answer in the chat and you can put it in as a fraction, a decimal, or a percent. Okay, 3, 2, 1, go. Look at that, nice. So 4 over 6, which would simplify to 2/3, and some of you gave me the percent, 66.7%. Make sure you have a percent sign there if you're giving me a percent, okay? Otherwise, the decimal would be 0.6667. Okay, so be careful on that one. Any questions on where we got 4 out of 6? I think we're okay, or 2/3. How about this second question? The probability of tossing still 1 die and getting a 7. I'll give you about 20 seconds and you're going to type your answer in the chat, either a fraction, decimal, or percent. You can simplify it too. All right, 3, 2, 1, go. So how many 7s are on a single die? 6-sided dice? None. There's none. So it's 0 out of 6 or 0%. Does that make sense? I think some of you thought it was 2 die. You got to read very carefully. In probability questions, that's one of the biggest things is reading very carefully, just like in our stats questions. Okay. Now, try this next one. This one might be a little bit harder for some of you. It says, suppose you write each letter of the alphabet on a different slip of paper, and you put the slips into the hat. What's the probability of drawing one slip of paper from the hat at random and getting a vowel or a consonant? Now, we might have to review a couple things. How many letters are in the alphabet?
26.
There you go, 26 letters in the alphabet. Now, what does a vowel mean? Or what are the vowels?
A, E, I, O, U.
Very nice. A, E, I, O, and U. We're not counting sometimes, okay? Just A, E, I, O, U. And then what's a consonant? Anyone know? It's anything that's not a vowel, okay? It's the rest of the numbers. I mean letters, sorry. The rest of the letters. Okay, now you should be able to calculate both of those. Get both of those ready, either in a fraction, a decimal, or a percent, and then I'll just randomly call on you. All right. So the first one, the probability of getting a vowel. Lily, what did you get?
I got 5/26.
Very nice. 5/26, because there's 5 vowels, 1, 2, 3, 4, 5, and there's a total of 26 letters in the alphabet. If you did that as a decimal, you would get 0.1923. If you got it as a percent, it would be 19.2%. All right, how about a consonant? What did you get for a consonant? Matt, what did you get for that one?
80 point, let me check. 7, then round that, so 80.8%.
Very nice. 80.8%. Excellent. Did anyone write a fraction for that one? Yeah? What did you get for the fraction?
(21/26).
Very nice. 21/26. Everybody okay with that? All right. Excellent. Now, I'm going to give you a worksheet that I want you guys to work on in your teams. and it's going to be random teams today, but I want you to think through the problems. Call me in if you need help. One of the problems is a card problem, and I show you a deck of cards. So anytime I give you a card problem, I will give you the deck of cards so you can refer to them, because I know not everybody has the same experiences with cards. Okay? So this is what I want you to work on now. And this is the first question on that worksheet, just so you know. So when you get it, if it talks about balls in a box, it should be familiar. Okay, so I'm going to put that in the chat for you. Make sure you grab it out of the chat so you have this. Okay, so you know what the questions are, and then I'm going to put you in breakout room. All right. Say hi to your new team just for today, your fun random teams, and call me in if you need help. I'll come in and check on you. If you finish early, I still have way more to do, so don't think it's time to go. I just wanted to go over a couple things with you. I know you did not finish. That's totally fine. If you did finish, that's awesome, but you didn't have to. I want to go over a couple things with you. First of all, those first questions, my answers are in here. I know that some of you are still having rounding issues. Please follow the directions. If it says to 4 decimal places, it wants 4 numbers to the right of the decimal. Okay, and then on the percent, if it says round to the 10th, then you don't round until the very end. Okay, so hopefully you got these answers. On the decks of cards questions, some of you know decks of cards, some of you do not. If I ask you a deck of cards question on a test or a quiz, I will give you this image so you have it, so you can reference it if you are confused. Okay. So because we all don't know cards. Hopefully you got these answers for the card questions. Again, fraction, decimal, and percent. Excuse me, I'm yawning. And then I gave you the practice problems. You didn't finish. I'm going to post my slides after class, and you do have access to the key if you want to double check. That's a great way to check your understanding. So what do I want you to do tonight? You have PC1 homework that's due tonight on more. You also have a more mini lesson for PC2 that's due tonight. So you will be ready for class tomorrow, okay? And then you have an exit ticket. Please read the directions on the exit ticket. You can give me your answer as a fraction, a decimal, or a percent. Don't give me all of them. Just give me one of them, because it'll mark you wrong if you type a comma between them or an or between them. But if you give me the fraction, the decimal, or the percent, it should mark you correct or incorrect. All right, I'm going to give you time to do that exit ticket. I'll stay here if you have any questions. Otherwise, I'll see you tomorrow. Good work today. And come and visit me if you're stuck on anything.
Thank you, Ms. Clausen.
You're welcome. See you tomorrow. Zach, it's a rounding issue.
Yeah, I just looked at it at my at the score like the second you said it.
All right, good. Just make sure you pay attention when you're entering them, because it'll mark you wrong. Good job.
Okay.
Bye.
Bye. Good job, Matt. Annie, same thing, rounding issue. Okay, it said round to the nearest hundredth this time. So you can't round until the very end. Does that make sense?
Yeah.
Okay, so what would your answer be on that first one then?
46.15%.
There you go, perfect. Good job, Annie.
The second one, 15.38.
Yeah, so just read those directions. I'm guessing you probably just skipped that part.
Oh, okay. Thank you.
Okay, good job.
Thank you.
Yep, good job, Danessa. Good job, Josh.